Let ABC have AB equals 14, BC equals 30, AC equals 40, and triangle AB prime C prime with AB prime equals 7 root 6, B prime C prime equals 15 root 6, AC prime equals 20 root 6, and such that angle BAB prime is 5 pi over 12. The lines BB prime and CC prime intersect at a point D. Let O be the circumcenter of triangle BCD, and let O prime be the circumcenter of B prime C prime D prime. And we want to find the length of segment OO prime. So as always, we should draw a diagram for these type of geometry problems. So we end up having this length. This is ABC. Then we have, suppose, AB prime, then C prime. And then we have the lines BB prime and CC prime intersect at a point D. And the circumcenter, and now we want to find out where the circumcenter of BCD is. And if we go ahead and draw it in, it becomes very. This is a perpendicular bisector of BD and the perpendicular bisector of CD. It ends up being somewhere around, like, suppose here, like somewhere around here, which is very close to the circumcenter of ABC. So we might conjecture as a result that ABDC is cyclic. Because if that were the case, then that would make computations a whole lot more easier. And we're definitely hoping that this is the case. So how can we go about proving this? Well, we might note that triangle ABC and AB prime C prime are similar and we could notice this because 14 to 7 is 30 to 15 and is equal to 40 over 20. And we have a square 6 in front everywhere else. So triangles AB prime C prime and triangle ABC are similar. And the ratio of similarity between AB prime C prime and ABC, like you multiply by 2 over root 6 to get from AB prime C prime to ABC. So how can we use this similarity? And as a consequence, recall my video on spiral similarity, which states that if ABC is similar to AB prime C prime, and BB prime and CC prime intersect at a point D, then that means that the circumcircles of BCD and B prime C prime D prime intersect at the center of spiral similarity. But the spiral similarity is just center of spiral similarity is just A, which means that ABDC is cyclic by spiral similarity. So now that we know that this is true, the point D is entirely irrelevant. And now we just need to find the circumradius of each of these triangles. And this is not hard to do. So let's first find the circumradius of ABC. We have 14, 30, and 40 as our side lengths. And we can use the formula R is equal to ABC over 4K, where K is the area. And we indeed have that K by Heron's formula. It is S times S minus A times S minus B times S minus C, where S is a semi-perimeter A plus B plus C over 2, and A, B, and C are the side lengths. If we plug in 14, 30, and 40, we end up getting 14 plus 30 plus 40 over 2, and that becomes 42. And after this 42, we can end up plugging in. So we have 42 times 42 minus 14 is 28, 42 minus 30 is 12, and 42 minus 40 is 2. So there we go. And if we take out a factor of 7 in this, we end up getting 7 root 6 times 4 times 12 times 2, which is 7 root 24 times 24, which is 7 times 24, which is 168. And now, if we plug in back here, we get 14 times 30 times 40 over 4 times 168. This becomes 12 because 168 over 14 is 12. Then if we bring a common factor of 2 from here, we end up getting 60 times 20 over 12 times 4. This becomes 5, and this becomes 5, so that becomes 25. So now that we know that AO is equal to 25, do we have to do the same calculation for AO prime? Of course not, because we know the ratio of similarity from ABC to AB prime C prime is root 6 over 2. So that's 25 root 6 over 2. And now we've just reduced the problem to the following. If we have a triangle AOO prime with 25 and 25 root 6 over 2, and this angle's 5 pi over 12 because that's how much we rotate it. As we are given in the problem, we need to find out the length of OO prime. And we can do this by using the law of cosines. But first, let's go ahead and scale things down by a factor of 2 over 25. So we want 2 over 25 times new answer, where the new answer is over here. So if we have a triangle XYZ with this is 2 root 6 and 5 pi over 12, then we want this segment. And let's go ahead and let this be x. And then x squared by the law of cosines is 2 squared plus root 6 squared is just 6 minus 2 times root 6 times the cosine of 5 pi over 12. And then evaluating things, we get this is 10 minus 4 root 6 cosine of 5 pi over 12. But what is the cosine of 5 pi over 12? Well, it's pretty well known that the cosine of 5 pi over 12, which is just the cosine of 75 degrees for those who like degrees more, is root 6 minus root 2 over 4. If you want to derive this yourself, you can use it like cosine of 75 degrees is equal to cosine of 45 degrees plus 30 degrees. And then you can use the cosine addition formula from here. But either way, this ends up being 10 minus 4 root 6 times root 6 minus root 2 over 4, which is 10 minus root 6 times root 6 minus root 2, which is 4 plus root 12, which is 4 plus 2 root 3. And this is x squared. And that means that x is equal to root 3 plus 1. And now we need to multiply our answer by 25 over 2. So that's 25 over 2 times root 3 plus 1, which is 25 plus 25 root 3 over 2. And that's OO prime. And if we go back to our original question, we want to find out what A plus B plus C plus D is. So we have 25 plus 25 plus 3 plus 2, which is 50 plus 5, which is 55. Thank you so much for watching this video. Please subscribe if you'd like to see more.